Good afternoon. My name is Amberlee, and I would like to begin this presentation by first saying that there are actually 5 million traffic accidents which occur in America every year. And in fact, 17% of these accidents produce spinal injuries, which is quite shocking when you think about it. In fact, overall, 30% of all spinal injuries which occur in America are caused by traffic accidents. So because of this, our team has devised a brainwave receiver, which, with the help of 2 transducers and a receiver found in the leg, will actually be able to make a person walk. Essentially, how this invention works is the electrodes in the brainwave receiver will collect the electrical impulses from the brain and send all the information to the transducer found on top of the head. This transducer will in turn send the information to the receiver found on the side of the leg. This receiver will translate the information into muscle movements, and a second transducer, this time found on the leg, will emit electrical energy, which will travel down various wires located on the leg and shock the muscle tissues of the leg, resulting in movement. Our target audience for this invention is people with either bad nerve endings on the legs, otherwise non-severe spinal injuries, but it can also be used by anybody who has a mobility disorder. And now Matthew will continue to explain this invention more thoroughly.
So I'm gonna explain these diagrams in more detail. So first of all, the main part of this project are the electrodes, which will be attached to the head by the means of a headband or a cap. Now, these electrodes will pick up the signals from the brain and transfer them to the transducer, which will convert these signals to these electrical impulses into signals and send these signals down to the transducer in the leg. Now, this is so a wireless tunneling surgery is avoided. Now, in the leg, the receiver will send the signal to the transducer, and with the help of a battery, it will send electrical impulses to the main muscles in the leg. Now, these muscles are important for movement. Now, for a person to walk, obviously you cannot send the electrical impulses to both legs at the same time and not to all of the muscles, or else your leg will just raise and stop there. So, the order for a person to move is to raise the leg. A shock must be sent to the quad muscles and to the calf, while the shin and the hamstring will remain paralyzed. So he can lift the leg, and then to lower it, the opposite procedure will occur. Now, this procedure will occur from one leg to the other, because obviously it's pointless to just raise and lower the same leg. Just raise and lower the same leg so the person can move. Now, with this method, some wire tunneling surgery isn't avoided, because as you see here, some wires are passing to the muscles. Now, an alternative to this could be a medical e-tattoo. How this basically works briefly, because now James will explain it, is by a tattoo on the leg, which will pass from the transducer to the main muscles of the leg, and which will send the impulses. Now I'm gonna let James to explain the medical e-tattoo.
So, our brain transmitter will take the shape of a headband or a hat, as Matthew already said, depending on your preferences. What also sets us apart is that you have a choice between a wire tunneling system, Matthew already said that, or e-tattoo. If you want to go with the e-tattoo route, an e-tattoo has electrodes inside. You can see it in the picture, which is placed across the leg and transmits the signals from the transducer to the muscles. if you go to the wire tunnel in Madrid, you need to perform a surgery from wire, using the wire tunnel procedure, and an electrode will be placed at an end to stimulate the muscles. Statistics show that this procedure has a 93% success rate and a 0.15% of rate of infection. Now I'm introducing you to
Hi, I'm Malcolm. I'll talk about the benefits of this product. This product, our product reduces symptoms from these physical damages and also improves quality of life. Our product is rechargeable. It has a litmus ion polymer battery. This is wirelessly charged since the transducer itself is in a pocket inside the leg. This battery lasts about 2 to 3 years. The device itself costs about 1,700 euros and contains a non-invasive brainwave receiver, 2 transducers, one on the cap or headband and one in the leg, and two lithium-ion polymer batteries. Although this device is pricey, it enables us to do something that is very underappreciated, the ability to walk. Thank you.